So in this video, we're going to look at actually finding the trig ratios for 30, 60, 90s and 45, 45, 90s. So the first thing I want to look at is problem number 1 here. And I have a 30, 60, 90, but I don't have the sides labeled. So this is where it's important to know those information from the proofs that we did in the first video. So the side opposite of the 30 we're going to label as x. The side opposite the 60 is x root 3. And the side opposite the hypotenuse is 2x. Now, however you're going to remember those, remember them. It's really what makes sense in your brain, so keep track of it. Now, what I want to do is deal with the 30-degree angle first, and I'll take care of sine, cosine, and tangent. So if this is my 30-degree angle, this side is opposite, this side is hypotenuse, and this side is adjacent. So the sine of 30 is going to be the opposite over the hypotenuse. And when I reduce that, the x's completely cancel, and what I'm left with is 1/2. And that's it. It's just 1/2. If I look at the same idea for cosine, well, cosine is the adjacent side over the hypotenuse. So the x's are going to cancel, and I'm going to be left with root 3 over 2. Well, that's interesting. And last but not least is tangent. So tangent is opposite over adjacent. And this one I'm going to go ahead and slide over so I have a little bit of room here. So the x's are going to cancel, and you're going to have 1 over root 3. Now, something we did in first semester was to rationalize some problems. This is one that needs to be rationalized. So I'm going to multiply by root 3 over root 3, which turns it into root 3 over 3. All right. So what's interesting about this is no matter the size of your triangle, whether it could fit in the palm of your hand or it would take the entire, take up the entire parking lot at the high school, no matter what, if you're dealing with the sine of 30, it's going to be 1/2. The cosine of 30 is root 3 over 2, and the tangent of 30 will always be root 3 over 3. So that's kind of where this is heading towards, is knowing that, again, no matter what the triangle shape, size is, shape matters, but size does not, that is, if it's 30, 60, 90, these are the ratios. Now, let's see what happens if we talk about tangent. Now, for tangent, I'm going to do just a quick little redraw of my triangle so that I don't confuse myself with the other pieces I had labeled. So 30, 60, there's my right angle. All right, across from 30 is x, across from the hypotenuse is 2x, and then the third side is x root 3 here. So if we have 60 as our primary angle, our reference angle, the opposite side is going to be x root 3, the adjacent side is x, and the hypotenuse is 2x. So the sine of 60 is going to be opposite. So x root 3 over hypotenuse is 2x. So root 3 over 2. Cosine of 60 is going to be adjacent over hypotenuse. Cancel out the x's, and you're left with 1/2. We'll go ahead and box those up too. And last one, tangent of 60 is going to be opposite over adjacent, so just root 3 when it simplifies. One thing you might notice, and maybe you notice, maybe you don't, the sine of 30 is the exact same thing as the cosine of 60. The cosine of 30 is the exact same thing as the sine of 60. They're considered complementary angles to each other. And so the complements are the other trig functions. So it's kind of weird, but it always works that way. So we now have the 30, 60, 90 done. And we're going to take care of the 45, 45. Now, 45, 45 only has one set of problems, because whether you're dealing with this 45-degree angle as your reference or this 45-degree angle as your reference, you're going to end up with the same thing. All right, so let's say I do this one. Doesn't really matter. Okay, I'm just picking that one for giggles. Opposite side is going to be x. Opposite side here is x, and the hypotenuse is x root 2. So if that is the angle that I'm dealing with, then this is going to be opposite, adjacent, and hypotenuse. All right, sine of 45 is opposite over the hypotenuse. Well, that's going to turn into 1 over root 2. When you rationalize that, and yes, you need to rationalize these, you get root 2 over 2. Okay, so the sine of 45 is root 2 over 2. Now, if we do the cosine of this 45-degree angle, the adjacent is x, and the hypotenuse is x root 2, which should look distinctly familiar because it's the exact same thing we had in this last one. So yes, you could show me this step. I'm going to be a little lazy and just say, I know this turns into root 2 over 2. All right. So the sine of 45 degrees and the cosine of 45 degrees are identical because the opposite and the adjacent are identical. So that makes sense. Last one here is going to be tangent, and the tangent of 45 is opposite over adjacent. So that's going to be 1. All right, tangent of 45 is always 1. All right, I'm going to go ahead and close the video here. There's a second page that I'll get to in a separate video, but just make sure that you know how to transition those sides that we found from the informal proofs to actually finding the trig values for 30, 60s, and